Okay, another video on joins. For those who have been following me know that I have made several videos, several small videos on joins. But unfortunately, joins can be very intimidating and can be very confusing. And the reason, one of the reasons is that different vendors can have different names, can use different names for the same thing. And also because there is a lot on the internet, there are a lot of definitions and there are several different ways in which the joins have been described, and when you read two different articles you can get confused. Now the good thing is there is an international standard, NCSQL, and all vendors, all relational database vendors, that includes Oracle, SQL Server, IBM, and Sybase, etc., etc., they have to match these standards. Okay, so remember there are four types of joins: cross join, inner join, outer join, and self join. A cross join is a Cartesian product, means every row in one table will be joined to all rows in the other table. So if table A has 4 rows and table B also has 4 rows, and you cross join those two tables, you'll have 16 rows as a result set, which is not very useful in most cases, but you should know about this type of join. You should know about the Cartesian product if you want to be professional in SQL. The inner join, the most common type of join that you'll have to use in real world. It is known as equi join in Oracle terms. And the third type is outer join, and then there is a self join. Today we'll spend most of the time in describing inner joins and their different subtypes, I would say. Okay, so we are connected to HR schema that has an employees table and a department table, employees and departments. So if I select this statement, if I run this statement, select all from employees, it will show all data in this table. And notice there are 107 rows, and other than employee ID, first name, last name, and other details of the employees, you also have a column by the name of department ID. Notice you can find out the department number, department ID of an employee, but cannot find the name of the department an employee is working for. So there is another table called departments. If you run this statement, select all from departments, you have 1, 2, 3, 4 columns in it. And in this table you have department ID and department name. Now to make things simple for this video, I want to create a subset of employees table as well as a subset of department table. So first I'm creating a table called emp, and I'm selecting columns from employees table, and I'm selecting 1, 2, 3, and 4 columns. So I'm creating a subset of columns. So employee ID is being renamed as EMP ID. First name is being renamed as F name. The last name is being renamed as L name, and the department ID is being renamed as DEPT ID, and it will copy the data as well. The statement will not only create emp table, but the columns will have data, exactly the same data that was in this table. Okay, so run this, and table emp has been created. And if you select all from EMP, you have 1, 2, 3, 4 columns: employee ID, first name, last name, and department ID of the employees. Okay, so much better to understand. Similarly, I'll create another table called DEPT, and same thing. Okay, table DEPT is created, and if you select all from DEPT, you have department DEPT ID and the name. Okay, so department 10 is administration, department 20 is marketing, and so on and so forth. Okay, the traditional way that Oracle used before NCSQL standard. So this used to be the traditional way to join two tables. Select all from name of the first table, comma, name of the second table, where clause, and here we're defining that this column, and that's how you write it, emp.deptid. So you're saying this is the source table, emp.deptid, this is the name of the column in this table, is equal to dept.deptid is equal to the column called department ID, deptid, in this table. Okay, so equi join should make you think of the equality symbol. So when one side of the equation is equal to the other side of the equation, then join the tables. Okay, notice where clause is already consumed. So if you run this statement, you see employee ID, first name, last name, and the department ID is displayed twice here, but the tables have been joined. As you can see, Stephen King belongs to executive department, and this gentleman belongs to IT, David Austin belongs to IT, Diana Lawrence belongs to IT, Nancy Greenberg belongs to finance, and so on and so forth. Notice there are 106 rows as compared to 107 rows in employees table. Okay, so there are 107 rows in this table. There's one employee that does not belong to any department. The department number is null, department ID is null, so this employee is not displayed in this result set. There are only 106 rows. Okay, so this used to be the traditional Oracle syntax, equi join. This is not NC SQL standard. The equivalent of equi join is known as inner join in NC SQL standards. Okay, so you can join these two tables with the help of inner join. Now there are three types of inner joins, or inner join uses three different keywords. One is natural join, the other uses keyword using, and the third one uses on. So all three are inner joins, and they'll give you the same results. The first one is known as natural join. If you run this statement, select all from amp natural join dept. Notice you don't even have to describe the name of the columns, so it will give you exactly the same result, 106 rows. Notice the department ID is displayed once only, and the name of the department is visible here as well. Okay, but the problem with this join is because you don't specify the name of the column, the results can be sometimes wrong. If I use employees table instead of EMP, and if I use departments table instead of DEPT, if I run this statement and I see select all from employees, natural join departments, notice 100 instead of 106 rows you have 32 rows only. So what it has done, it has chosen a random which it thought were the joining columns in two tables. So this type of join is not recommended in most situations unless you're absolutely sure what you're doing. So it can give you wrong results. Now the more trustworthy inner join uses the keyword using. So select all from EMP, inner join DEPT, using department DEPT ID. Okay, so if you run this statement, you'll have exactly the same results. 106 rows, department ID is displayed once, and department name is visible here. But the problem with this statement is it is only useful if both tables have exactly the same columns name. You can join a table with another table and both tables can have two different column names. You only have to have same data type. So in this case, if employee table had a different column name and department table had a different column name, this query will fail. The third form, which experienced professionals seem to gravitate towards is select all from EMP, inner join the EPT on, then there's a joining condition, emp.dept id and dept.dept id. So in this case, if the name of this column was different to the column in the EPT table, you can still use that. Okay, same results. I just want to show you one more thing before we go any further. I just want to go back to the traditional Oracle syntax. Equi join, this one, select all from EMP comma DEPT, so name of two different departments, and notice we're already using where clause. So what if you wanted to see a subset of rows? Say for example you wanted to see only department number 90 or department number 20 or department number 10. Where clause is also is already used in this one. But although you can say and dept.dept id is equal to 90, so it will give you the required result. So it's showing you the data from dept id number 90 only. But the thing is, when you're running this, you're parsing. You have to think about the parsing, how much time this statement will take as compared to other inner join, and that becomes very, very important. Okay, so I have shown you so far 1, 2, 3, 4 and 5 different statements that will give you exactly the same result. Because inner join is the de facto type, you can run an inner join without using the keyword inner. So if you say select all from EMP join the EPT using the EPT ID, notice you have removed the keyword inner join. The database engine will assume that it is an inner join. Okay, same results, and the same thing is true for the other statement when you're using on keyword. Now this will give you a Cartesian product, but you can also say select all from EMP cross join the EPT where emp.dept id is equal to dept.dept id. This is not technically a cross join anymore because you're using where clause. Okay, so if you run this statement, you'll have exactly the same results, 106 rows. Thank you very much, and in next videos I'll try to explain the other types of joins.